Hello everyone and welcome to my channel Chemistry Unfolded. This is the part 2 of coordination chemistry. We are going to study about isomerism and coordination compounds. So let's revise whatever we have studied in previous lecture. First question. Coordination number of the given complex is. What is the coordination number? Coordination number is the number of ligands attached to the central metal atom. So here we see that 8 cyanides have been attached to molybdenum. So the coordination number here is 8. So let's check if the answer here is correct. Yes, it is 8. Coming to the next question. The primary and the secondary valencies in the given complex are dash and dash respectively. Primary valency relates to the oxidation state and the secondary valencies relate to the coordination number. So the oxidation state of the given complex is +3. We must sit and calculate the coordination number first, and the secondary valencies is the number of ligands attached to the complex. So here we see that 5 ammonia and 1 chlorine is directly attached to the complex. Therefore, the coordination number is 6. So the correct answer is primary valency 3 and secondary valency 6. Let's check out. Okay, correct. So next, so here we must find out whether the given complex obeys the EAN rule or no. So let's calculate. Cobalt +3. This gives 24 electrons and the 6 ammonia give 12 electrons. So the total becomes 36, which is the effective atomic number of an inert element. That means this complex obeys the EAN rule. So let's start with isomerism. There are two types of isomerisms in general, structural and stereo. Structural has 5 subtypes: ionization, hydrate, linkage, coordination isomerism, and ligand isomerism. Stereoisomerism has 2 types, geometrical and optical. So let us learn about structural isomerism in today's video. What is structural isomerism? These isomers have different atom to atom bonding. In coordination compounds, the structural isomerism arises due to different connections between metal and ligand. So first up we have ionization isomerism. When does this isomerism occurs? This isomerism occurs between the coordination sphere and the ionization sphere. There is exchange of ligands which is observed. So let us see in the given example. In the first example, we see that the bromine is inside the coordination sphere and sulfate is in the counter ion. But what we see is that later on there is exchange. Sulfate goes inside the coordination sphere, whereas bromide remains out. Similarly here, bromine here will go in the coordination sphere and chlorine will come out. That each of these isomers has a different color, like this one will have one color, this one will have another color. Coming to linkage isomerism, this is seen when you have an ambidentate ligand. What's an ambidentate ligand? It's a ligand that has 2 donor atoms. Like if you see NO2, it can donate through nitrogen, also through oxygen. Like if you see SCN, it can donate through sulfur, also it can donate through nitrogen. Okay, in such cases you get to see linkage isomerism. The third one is hydrate isomerism. This one, when you see, when there is something called exchange of water molecules taking place between the coordination sphere and the ionization sphere. For example, this complex sees 3 hydrate isomers of it. Each one has a different color. Like in the first example, all the water molecules are in the coordination sphere. But during the isomerization process, each water molecule leaves the complex, and therefore you get to see different colors. Coordination isomerism. Here what happens is that there is an exchange of ligands between the complex ions. This is one complex ion and this is the second complex ion. What you see is that the ammonia ligand, which was first with cobalt, will now go to chromium, and the cyanide, which was with chromium, will now go to cobalt. Okay, that is called coordination isomerism. Then we see ligand isomerism. This isomerism occurs if a ligand exists in 2 or more isomeric forms. Okay, that is, if the ligand itself has isomers for it. Like if you see this 1,2 diaminopropane and 1,3 diaminopropane, the molecular formula of these two is the same, but what happens is the structure of these two are different, and therefore you see ligand isomers. You have examples, other example like orthometaperatoluene. Thank you. If you like the content, please like, share and subscribe.